This lesson talks about formulas. It goes from anything from being able to solve a formula for a certain variable to creating formulas from English. So it's lots of different tools that you'll need in this course. So first of all, I'm just going to start off with an example. E is the life expectancy of U.S. women, and T is years after 1950. So according to this model, E equals 0.177T plus 71.35. And the question is, in what year would the life expectancy of U.S. women be 82? So one thing you need to make sure you know is be able to identify the variables you need. Now they're asking us, sorry about that, they're asking us in what year? Well, years is T. So we're going to be looking for T. This is what we're trying to find. Now what they tell us is that the life expectancy will be 82. Life expectancy is E, so we'll be plugging 82 in for E. So let's do that down here. We'll have 82 equals 0.177T plus 71.35. So then you can subtract 71.35 from both sides. You get 10.65 equals 0.177T. And then we will divide both sides by 0.177. And use this for that. There we go. 10.65 divided by 0.177. So we get about 60.169. So T equals 60.169. But one important thing, we haven't really finished the question yet. We've done all the math correct. It's not that we're wrong, we're just not finished. Because they asked in what year it would happen, and 60 is not the year in which it would happen. So go back to what T says. T is the years after 1950. So that means it's going to happen 60 years after 1950, which would make it the year 2010. Now I want to go ahead and talk a little bit about this equation. If we look back up at the original equation, it's a linear equation. And linear equations have two very important components. They have their slope, which for this is 0.177, and they have their y-intercept, which in this case is 71.35. It's important to remember that slope represents the change. It's the change in y per x. And E will represent our y here, and T will represent our x. So it's the change in life expectancy per year. Specifically, since it's positive, we know that they expect the life expectancy to increase by 0.177 years per year after 1950. The y-intercept, 71.35, represents the amount of y, or in this case E, in when x equals 0, or in this case t equals 0. So that's 1950. So 71.35 is the life expectancy of U.S. women born in 1950. Alright, let's look at another example. This is one of those cases where you're going to have to take the English that's written as a sentence and turn it into an equation. There are 7.5 million more cats than dogs in the U.S. The number of cats and dogs combined is 114.7 million. Determine how many cats and how many dogs there are. Okay, so start with the very first sentence. There's going to be two equations here. There are 7.5 million more cats, and we're going to call that C, than dogs in the U.S. So there are more cats than dogs. So we can write it as the number of cats is equal to the number of dogs plus 7.5 million. And we'll just keep it in terms of millions so we don't have to write that every time. So the number of cats is equal to the number of dogs plus 7.5 million. And if you look closely at that equation, it says exactly what it should, that the number of cats is bigger than the number of dogs, because the cats is equal to dogs plus more. Alright, now let's look at the second sentence. The number of cats and dogs combined is 114.7. So if you take the number of cats and combine it or add it to the number of dogs, you should get 114.7. So what we've just created is called a system of equations. That just means there's more than one. Now we can use substitution, which is probably the simplest in this case, to solve that system of equations. Here's what that means. We know that C equals the same thing as D plus 7.5. So I can replace c anywhere with d plus 7.5. So I'm going to take d plus 7.5 and plug it in to this equation. And that's going to give me d plus 7.5 plus d equals 114.7. So again, I took this second equation right here and I replaced the c with what I knew c was equal to, and that is d plus 7.5, and I have it right here. So then I can combine my like terms. D plus d is 2d. I can subtract 7.5, 107.2, and then finally divide by 2. So if I divide that by 2, oh goodness, 107.2 divided by 2, 53.6, alright? So 53.6 million dogs. Now at this point we need to find out how many cats there are. We now know the number of dogs we saw for D. And you can go back and plug this into either one of these equations. So you can plug 53.6 in here and solve for C, or here and solve for C. Completely your prerogative either way. I'm going to use the top equation just because that's what I want to do. So we put 53.6 in for D, and then add 7.5 to it. So we get that C is equal to 61.1 million cats. So there are 61.1 million cats and 53.6 million dogs. Okay, here's another way you can write equations and make it useful. Choosing a cell phone plan. Plan A costs you $20 a month. It's a flat fee you have to pay no matter what. And then they charge you 5 cents a minute for every minute you talk. Plan B costs you $10 a month for a flat fee no matter what. And then it's 10 cents a minute. So let's just, before we get into the math problem, talk about this a little bit. Plan A starts off more expensive. It's $20 a month. But it only charges you 5 cents a minute. Plan B starts off cheaper, $10 a month. But then they charge you more per minute, 10 cents a minute. So hopefully your intuition is already telling you, well, if I'm going to talk a lot, then Plan A is probably going to save me money in the long run. Because even though it's $20 to start with, since it's only 5 cents a minute, after I talk a long time, that should pay off since it's only 5 cents a minute. Whereas Plan B will be better if I'm not going to talk a lot on the phone, because it starts at $10 a month. So the fact that I start off $10 lower means that that 10 cents a minute won't hurt me too bad as long as I'm not talking very many minutes on the phone. So now to get back to the problem and what it asks, it says write a system of equations that describes the cost of the two plans. So we need to write these in terms of an equation. Okay, well the first plan costs you $20 a month no matter what. So think of that as your starting fee. Well, if you think about linear equations, what you start with is your y-intercept. That's what you equal when x equals 0. So we know we're going to have a plus 20 for plan A. And your slope is how much you increase per x. Well, if we call x the number of minutes, we increase 5 cents a minute. So I'm going to put 0.05x. Because if you think about it, 20 is a fixed cost. It does not change. You have to pay $20 a month no matter what. The 5 cents a minute is going to be multiplied by the number of minutes that you talk. So then plan B, I'm just going to put an A here so that's plan A. Plan B is going to cost you 10 cents per minute, so 10 cents times the number of minutes you talk, plus $10 that you have to pay no matter what, flat fee. So that would be our system of equations. Again, system just means there's more than one. So then they ask how many minutes would make the plans cost the same. So like we talked about, plan A is likely to be a better choice if you talk a lot. Plan B is likely to be a better choice if you talk a little. But what's the separation between a lot and a little? Is it 50 minutes? Is it 100 minutes? Is it 500 minutes? Is it 1,000 minutes? At what point does it become better to do one or the other? Okay, well again, you've got to think of what the English words mean in terms of math. It said make the plans cost the same. Well, think about what the same would be in terms of math. That would be equal. So if we want to know when these two plans are the same, we want to know when they are equal. So I'm going to take the two of them and set them equal to each other. As you can see, I've done right there. Now it's just a matter of solving for x. So I subtract 0.10x. I get negative 0.05x plus 20 equals 10. I subtract 20 from both sides. And then divide both sides by negative 0.05. So negative 10 divided by negative 0.05 is going to give you 200 minutes. So that is the cutoff. If you're going to talk for 200 minutes, it really doesn't matter which plan you choose. You're going to pay the same amount of money for each one. But if you talk less than 200 minutes, plan B is going to be better because it starts with a lower cost of $10 a month. If you're going to talk more than 200 minutes, then plan A is going to be better because it's going to, even though it starts at $20 a month, it's less per minute in the long run, and that will help. Okay, last two questions. And this is a lowercase l, by the way. I'll make it cursive to make it easier to see. It says solve 2l plus 2w equals p for w. So first of all, I want to make sure you understand this is not asking for a numerical answer. We're not trying to find what w equals in terms of a number. What they're asking us to do is rewrite the equation. Right now we would say the equation is solved for p because p is by itself. So they're asking us to rearrange the equation or manipulate the equation so that w is by itself. So the first thing I'll do is subtract 2l from both sides. And I get 2w equals p minus 2l. There's only one more thing I have to do to get w by itself, and that's divide by 2. So w equals p minus 2l over 2. Alright, so the second equation, a equals p plus prt, solve for p. Now this one's a little trickier because it wants us to get p by itself, but there's more than one p floating around. So what do? Well, here's the trick. Anytime you have more than one and you're trying to solve for it, the key is to factor. If you look at these two pieces, they both have a p. So you can write that as p times 1 plus rt. I've pulled the p in common out front. If that's not real clear to you, think about working backwards. If I look at what I have now and distribute the p times 1 is p. P times rt is prt. So what I have is the same thing. P times parentheses 1 plus rt. So now if I want to get p by itself, I just divide both sides by 1 plus rt. So we get p equals a over 1 plus rt.